This is lesson 1.5. We are going to be talking about and practicing using functions, function tables, and other representations for functions. So just some really important vocab that you should be writing down. A function is a relation in which each member of the domain is paired with exactly one member in the range. So remember, our domain is our x values and our range is our y values. So what a function means is that every x, so every x value goes to only one y. A function rule is the operations performed on the x to get the y. Function table lists the x, the rule, and the y. And then an equation is a mathematical sentence stating that two quantities are equal. First example here says to copy and complete the mapping diagram. So a mapping diagram is really just these two ovals, and it's kind of like we're laying out our domain and we're laying out our range. So our x and our y. Our students are going to represent our x values, and the number of minutes is going to represent the y values. So we're going to look at these like they're ordered pairs. First thing we need to do is we need to fill in our range values. Our domain values are already there, 1, 2, 3, but we got to fill in the range. So we have 400, 400, and 750. We only have to write that 400 one time, because remember, any number that repeats itself, we just write it once, and then 750. Now, to complete a mapping diagram, we draw lines to connect the x to its y. So one student, 400 minutes. So we're going to connect the 1 to 400. Student number 2, 400 minutes. So we connect the 2 to the 400. And then 3 students, 750. So we connect the 3 to the 750. So letter B says write the relation as a set of ordered pairs. So when we're working with a set, we can start with our little fun squiggles, and then we can fill in our ordered pairs. So just like we did the x to the y, we're just going to write this here as our x value of 1, our y value of 400. The next ordered pair has an x value of 2 and a y value of 400. And our last ordered pair has an x value of 3 and a y value of 750. And then I can close that with the fun brackets. Letter C says, is this relation a function? Here's how to tell. When you have a mapping diagram, you're going to look at the lines coming out of your domain values. Remember, every x can only go to one y. So if there's any x's where two lines are coming out of it, it's not a function. But in this case, every x has only one line coming out of it. So yes, this is a function. And we can write every x goes to only one y. The second one, we're going to do the same thing. We have another mapping diagram. We have our x and our y values. And in our chart, again, students is going to be our x. Number of minutes is going to be our y. Our domain values are already written in our x oval. So we have 1, 1, 2, 3. We only have to write that 1 once. And then our range values, we do it from least to greatest. So I see there's 2 400s. I only have to write that once. Then we have 600. Then we have 750. And now that I've filled in my y oval, I'm going to connect them. So I see 1 goes to 600. I have 1 going to 400, 2 going to 400, and 3 going to 750. The next step is to write it as a set of ordered pairs. So again, I do those fun squiggles, and I just write them as an x and a y, an ordered pair. So our first one is 1, 600. Our next ordered pair would be 1, 400. Then we have 2, 400. 3 750. And we can close this off with our fun bracket. So letter C says, is this relation a function? So again, we're going to look at those lines coming out of our domains. And what do we see here? OMG, 1 has 2 lines coming out of it. So no, this is not a function. We can say the number 1 goes to 2 y values. So that is not a function. Okay, this next one, we're going to skip those first few steps. We're going to skip to step number 3, which says figure out what the next 4 figures in this pattern would look like. So here we have a table with x and y values. We have when x is 1, y is 6, x is 2, y is 9. When x is 3, y is 12. So what's happening here is we're going up by 3. So I can figure out the next numbers by just adding 3 to each term. So 12 plus 3 is 15, plus 3 is 18, plus 3 is 21, plus 3 is 24. So we've filled in our table, and then it says to graph the data. So remember our table, our x and y, we can write those as ordered pairs. For example, the first one would be 1, 6. Second one would be 2, 9. So let's graph those in order. So we have to go over 1, up 6, plot our point. Next one is 2, 9. So we go over 2, up 9, plot our point. Then we have 3, 12. So over 3, up 12. Over 4, up 15. Over 5, up 18. Over 6, up 21. And over 7, up 24. So we have filled in our table. We have graphed this. And then step number 5, it says, does this data represent a table? Well, let's look at it. Each x value goes to only one y value, which means yes. And to explain that, we can write every x goes to only one y. And then our last step for this one is to write a rule to determine the number of cubes for any figure number. So because we have plus 3, we know each term is going up 3. We know that there's going to be a plus 3 somewhere in our equation. To figure out what comes first, we have to figure out, we can look at any of these numbers. So let's look at this first one, 1 and 6. What times something, what times 1 plus 3 gets us 6? So what times 1 plus 3 gets us 6? The answer would be 3, because 3 times 1 is 3, plus 3 is 6. Which means for each term, we're going to take 3 times that number plus 3. And then let's check to see if it works. So if we plug in the next one, if we plug in 2 for x, 3 times 2 is 6, plus 3 is 9. If we plug in 6 for x, 6 times 3 is 18, plus 3 is 21. So our answer is 3x plus 3. And again, we found that we knew there was going to be a plus 3, and then we just problem solved and asked ourselves, okay, how would we get the answer of 6 starting from 1 when we know we have to have a plus 3 in there? The next problem says to make a function table for 4 different input values and write an algebraic expression for this rule. Double a number and subtract 1. So double a number means 2 times a number. So we write that as 2x, and then subtract 1 would be minus 1. So that's our rule, 2x minus 1. We can pick any numbers we want for our input. I'm just going to go with 1, 2, 3, 4. Then all I have to do is plug in the x to the rule to get my y. So I'm going to plug in 1 for x first. 2 times 1 is 2, minus 1 is 1. Next one I plug in a 2 for x. 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. Then we have 2 times 3 minus 1. Again, I'm just plugging in that x value into my rule. 2 times 3 is 6, minus 1 is 5. And then the last one is 4. 2 times 4 minus 1. 2 times 4 is 8, minus 1 is 7. So then it says, what is the domain and range of the function? Well, remember the domain is all of the x values in order from least to greatest. So here we have 1, 2, 3, 4. Easy for us. And we do it with those fun little squiggle parentheses. Our range is all of the y values in order from least to greatest. So again, they're already in order for us. 1, 3, 5, 7. This summary here is showing us how we can have multiple representations for one thing. So if we have the equation d equals 60t, we could have that in words. Distance is equal to 60 miles per hour times the number of hours. We could have it in a table. We could have it in a graph. So there's multiple ways that we can show the same thing. So this next problem says an assembly line produces 30 boxes per hour. Write an equation to find the amount of boxes it can produce for any number of hours. Let n represent the number of boxes and h represent the number of hours. So we have this expression 30 boxes per hour. So we know it's going to be 30. We know our hours is h, and per is multiplication. And this together is going to equal the number of boxes. So we can write that as n equals 30h, because when we have a number and a variable, we need nothing in between. Letter B says make a function table for 5, 10, 15, and 20 hours of production. Then graph the ordered pairs. So our input is going to be our hours, and our output is going to be the amount of boxes. Our rule is 30h. So we're given 5, 10, 15, and 20 hours. So we're going to fill those in for our h values. And then all we have to do is plug them into the function rule and solve for the output. So we have 30 times 5, which is 150. We have 30 times 10, which is 300. We have 30 times 15, which is 450. And we have 30 times 20, which is 200. Not 200, 600. And then it says to graph these ordered pairs. So remember, in this case, instead of doing x, y, it's going to be h and then n, which is the exact same thing as x, y, just using different variables. So our first ordered pair would be 5, 150. So I go over 5, up 150. Then we have 10, 300. So over 10, up 300. Then we have 15, 450. And last, 20, 600. So we've written our equation. We have made a table, and we have graphed that. And the last one here, Jenny makes $6 an hour at her after-school job. Write an equation to find the amount of money that she works, find the amount of money that she can earn for any number of hours. So she makes $6 per hour. We can just write that as 6x, because we know per is multiplication. Then it says make a function table to find the amount of money Jenny earns for working 10, 20, 30, and 40 hours. So again, we're already given our x values. We can plug those in. We can plug in our rule of 6x, and then all we have to do is plug in the x values to the rule and solve for y. The last thing is to graph them, but I know that you guys can do that on your own.